Hey guys, welcome back to another lesson video. Almost couldn't say that. Today we're going to talk about part 2 of this lesson with Pythagorean theorem and its converse. We're going to talk about the triangle inequality, which is right behind me, and then how does that relate to Pythagorean theorem and how we can use that to help identify triangles. Okay, so let's go ahead and jump right into it. So the triangle inequality theorem, which is something that you probably are familiar with already, so just as a recap, it pretty much says that any two side lengths, if we add them up, has to be greater than the third side of the triangle. Okay, if that isn't true, I technically can't make or form a triangle with those measurements. Okay, now because we have three different possible combinations of sides we can add together to see if it's bigger than that last remaining side, when we check our work to make sure that this is actually going to make a triangle, we have to go through each possibility. Okay, let's just jump into an example. Let's do this. 8, 15, and 17. Okay? Let's say I was trying to cut pieces of wood out. I'm trying to see if I can make an actual whole triangle. Okay? I'm looking for a triangle that I can make. It doesn't do this, or it's incomplete, or worse, it doesn't overshot the side. Okay? I'm trying to find a triangle that actually goes together by using this inequality theorem. Looking at this, let's go ahead and just pick two random sides. So we can say 8 and 15, is that bigger than 17? Well, I think so, right? That's 23 is bigger than 17. So I think we're good with that. Now, let's pick two other sides. 15 and 17. Okay, is that bigger than 8? I think so, right? That's 32. And then lastly, 17 plus 8. Is that bigger than 15, the last remaining side? And it is. We have 25 is bigger than 15, which is a true statement. So what I can establish is that, yes, these measurements form a triangle. Okay, 17 obviously being like the hypotenuse of the triangle, it's the largest side, but I am capable of making that. Okay? Now, what happens when this goes bump? Well, let's take a look at an example where that could happen. Let's say I was given those three measurements, and I want to figure out, can I make a triangle with this guy? Well, using the inequality theorem, let's take a look at it. 6 plus 8, is that bigger than 14? No. 14 is not bigger than 14. It fails, okay? Therefore, I cannot make a triangle with those measurements, whether it's in feet, inches, centimeters, kilometers, I don't care what we're looking at, whether it's an oversized map or just building a triangular structure, you cannot make a triangle with those measurements, okay? So, inequality theorem, can you make a triangle? Biggest thing there, okay? Now, let's change it. What if I know two sides of the triangle and I want to know what sides I could use for that last remaining part, okay? So let's take a look at this. 3, 7, and then a mystery side. So what can I do to figure out what numbers I could put into here that would make a triangle? And you're probably guessing that there's more than one answer, right? There's going to be more than one answer there. So that mystery side length, how can I figure this out? Well, algebraically we could figure it out just by using the inequality theorem, okay? What I'm going to do is change this to an x. I don't know what this remaining mystery side is, but let's go ahead and try to prove the inequality theorem with it. And you're going to see what happens algebraically when we do this. 3 plus x, is that bigger than 7? Okay. Now, if I was to solve this, I would subtract 3 to the other side, right? So I get x is greater than 4. Now, notice something here. That's telling me that my remaining side, my third remaining side, has to be bigger than 4. Okay. I'm getting a range of values, it looks like. Sorry, I have like hiccups again. All right, now we're going to go ahead and look at another set of sides. How about, I don't know, x plus 7 is greater than 3. Subtract 7, I get x is greater than negative 4. Now, already you could probably tell that this is not good. -3 is not going to work for this guy because, once again, we're talking about an actual geometric shape, okay? And I want that geometric shape to have positive measurements. You can't have a negative measurement when building something, okay? And then the last one would be 7 plus 3 has to be bigger than that last remaining side. So we get 10 is bigger than x. And let me just scroll the camera down. Oh, sorry, a little further. Okay. Now notice, this one, we're going to cross out. It was a bad inequality. These two here are good inequalities. Look what happens. My x value, my third remaining side, has to be less than 10. And then up here, my third side has to be bigger than 4. Now that is giving me a range of values then. So this remaining side is between 10 and 4. If I put 5, 6, 7, 8, 9, those numbers will satisfy the triangle inequality theorem. Okay. Kind of cool, isn't it? That even with two measurements, I can still figure out what third measurement I need to make this guy. Okay. Now, through multiple practice problems dealing with this type of thing, you're probably going to start noticing a pattern here. And I encourage you, look at my notes for the other examples. You're going to see that, hey, wait a minute, 4 and 10. 10 is by adding these two guys together. That gives me the largest that x could be. Well, has to be beneath, I should say. And then if I subtract these guys, I get the minimum. I'm getting the minimum range values for what our x value has to be. That's kind of like the pattern when you start dealing with these guys, that you start figuring out, okay, what do I need to make that last remaining side? Okay? All right, now, how do we incorporate this with Pythagorean theorem? I am so glad you asked that question. Here it is. Okay? So this is the Pythagorean inequalities, okay? And notice, the first one we kind of know already. If the sides squared and added together equals the hypotenuse squared, we have ourselves a right triangle, okay? And we talked about that with the converse of the theorem as well. If the hypotenuse is bigger than the side lengths, okay, we know it's not a right triangle, it ends up being an obtuse triangle, okay, meaning there's one angle that's bigger than 90 but less than 180. And then if the hypotenuse is less than the sides added together and squared, we have an acute triangle here, okay? Meaning that we have an angle that's what, less than 90 but at least bigger than 0, okay? Remember, acute triangle means they all are less than 90, right? An obtuse triangle has one angle that's obtuse. You can't have two angles that are obtuse. We talked about that in previous lessons about different things like that, okay? So we're going to do two examples with this, and that'll be it. So let's go ahead and take a look at one example. So 7, 14, and 16. Now let's say I have these three measurements, and by the way, you could use the inequality theorem to prove that, yeah, you can make a triangle with this. I'm not going to go through that just to save time. Now what I'm going to do is plug this into the Pythagorean theorem and see what type of triangle I have. Now notice I don't have the legs or the hypotenuse marked, but we know the hypotenuse is the largest side, so this is C. And then these must be the A and B values. And because of the legs, it doesn't matter which one's A and which one's B. Okay, addition is commutative. We don't have to worry about that. All right, so we have 7 squared plus 14 squared equals 16 squared. Now, what I'm going to do is put a question mark right there because I don't know if it really is equal yet. I'm trying to figure that part out. Okay? So this is in the part of the video where I would say, hey, pause it and take a look at it. See what you can come up with. Okay? 7 squared is 49. 14 squared is 196. And then 16 squared is 256. And once again, I'm not quite sure. I'll continue the question mark. I don't know if it really is equal. All right, last step, add these guys. We get 245. Then we'll bring the 256 down. Okay, notice the hypotenuse is larger than this guy. Make sure I use the proper symbol. So that's greater than, right? So that means because the hypotenuse is bigger, this guy is a obtuse triangle for that one, okay? because the hypotenuse is bigger, which is what we say over there. Now, I know what you're thinking. The signs don't match up, Mr. McCullough. Well, I know that, and that sometimes happens, right? It depends on how you work the equation. If I were to flip this, let me put or. Or I could say 256 is greater than 245, just like that. And as you can see, yes, it does match up. But just be cautious with that. Don't always just read the sign. Don't always just look at the sign and then match it up to this guy. Make sure you're reading the sign carefully. Okay? So far, so good. Let's do one more example. Let's try, and I'm going to put it up here. Let's do 9, 40, and 41. I have those three measurements, and I want to see what type of triangle we have. So let's use Pythagorean theorem. And once again, I'm going to put a little question mark there because I don't know if it truly is equal to each other. So we have 81 plus 1600. Okay, does that indeed equal 1,681? Finish it out. We get 1681 equals 1681. Hey, that's a true statement. There we go. This is a right triangle. Okay, so this one is a right triangle, and this guy down here is an obtuse triangle because the hypotenuse is bigger than the legs. Okay, and there we go. So we have inequalities, which is just, can you make a triangle? Okay, that's what we just discussed here. Is it possible to make that triangle? And then over here, we incorporate the Pythagorean theorem to say, okay, it's possible to make the triangle, but what type of triangle are we making now? And just using the basic properties here, we could figure that out. Okay? So a lot of good, useful stuff in this lesson, just kind of compact together. But that's it. Okay? Hope you all are doing well. Please look at my notes online so you can kind of see the other examples and try to work those out. But until next time, I will see you all in the next lesson video. Take care.